everywhere you look, in every direction. The universe is filled with stars, billions of galaxies, each with billions of suns. Now here's the strange part. When night falls, the sky isn't bright. It's black. That shouldn't happen. If stars are everywhere, the sky should glow like the surface of the sun. There should be no darkness at all. Yet above your head is a vast, silent blackness. So what went wrong? Is something blocking the light? Did the stars turn off? Or is the darkness itself trying to tell us a secret about time, space, and the beginning of the universe? Tonight, we're going to answer one of the simplest questions ever asked and discover why it changes how you see the universe forever. Imagine starting from the most innocent idea possible. You look up at the night sky and you see darkness, sprinkled with a few stars. Now forget what you've been told and just think like a curious human being. If the universe is really full of stars, not just a lot of them, but everywhere, then why is most of what you see black? Here's the key idea. If the universe were infinite, eternal, and filled uniformly with stars, then every direction you look should eventually end on the surface of a star. There would be no empty lines of sight. Just like standing in a dense forest that stretches forever. You don't see darkness between the trees, you see trees. Replace trees with stars, and suddenly the night sky shouldn't exist as we know it. This isn't hand-waving, it's simple logic. Pick any tiny point in the sky and follow that line straight out. If stars go on forever and have always been there, that line must eventually hit one. And stars are not subtle things. Even a small star is enormously bright compared to darkness. Add up the light from all those stars in all directions, and the sky should glow, not faintly, but brilliantly. It should be white, hot, comparable to the surface of a star itself. But it isn't. This contradiction is the heart of the problem. It's not a technical issue, it's a conceptual one. Something in our picture of the universe must be wrong. And this is exactly the kind of situation where science gets interesting, when common sense and observation don't match. For a long time, people tried to patch the problem instead of questioning the picture. Maybe stars are too far away, they said. But distance alone doesn't save you. When stars are farther away, each one gets dimmer. Yes, but there are more of them. The decrease in brightness is exactly balanced by the increase in number. You don't win anything by pushing stars farther out. Others suggested that clouds of dust absorb the light. But dust isn't magic. If it absorbs light, it heats up. And if it heats up, it radiates. Given enough time, the dust itself would glow just as brightly. So that explanation collapses too. What this first key point really teaches us is not the answer, but the mistake. The mistake is assuming the universe is static, infinite in time, and unchanging. That assumption feels natural. After all, the night sky looks calm and eternal. But nature doesn't care about what feels comfortable. The darkness of the sky is a clue. It's telling us that the universe cannot be infinite and eternal in the simple way we imagined. If it were, the sky would be blazing. The fact that it's dark means there must be limits. Limits to time, limits to light, limits to how long stars have existed. So before we even talk about the Big Bang, expansion, or cosmic background radiation, this first idea already cracks the old picture of the universe. The night sky is not just scenery, It's evidence. Evidence that the universe has a history, that it hasn't always looked the way it does now, and that asking a question can quietly dismantle a centuries-old assumption. That's the beauty of it. A simple observation, a simple question, and suddenly, the universe can no longer be eternal, calm, and obvious. Once you accept that the dark sky is a real problem, the mind naturally tries to escape it with easy explanations. And the two most tempting ones are distance and dust. They sound sensible. They feel like they should work. But when you slow down and think carefully, they quietly fall apart. Let's start with distance. It seems obvious that faraway stars would be too dim to light up the sky. After all, a nearby street lamp is bright, but a distant one fades into darkness. So maybe the universe is full of stars, but they're just too far away to matter. Here's the catch. When you move stars farther away, each individual star does become dimmer. But at the same time, you're adding more stars, many more. In fact, the number of stars increases so fast with distance that it exactly compensates for how much dimmer each one becomes. For every step outward, the universe gives you a larger shell of space packed with new stars. The light lost from distance is replaced by sheer quantity. This isn't a trick or a coincidence, it's geometry. The surface area of a sphere grows with the square of its radius. So when you double the distance, you get 4 times as many stars contributing light. The dimming and the increase cancel out perfectly. Distance alone cannot darken the sky if stars extend infinitely in all directions. Now try dust. This idea is even older and even more intuitive. Maybe clouds of cosmic dust sit between us and the distant stars, soaking up the light before it reaches our eyes. On short timescales, that works. Dust can block light. But the universe is not a short timescale system. Dust absorbs energy, and absorbed energy does not disappear. It turns into heat, and heated matter radiates. If the universe had existed forever, that dust would have had unlimited time to warm up. Eventually, it would glow just as brightly as the stars whose light it absorbed. The darkness would be replaced by a warm, steady shine, so dust can delay light, but it cannot destroy it. You can't make the universe permanently dark by hiding light behind curtains that themselves heat up. What's important here isn't just that these explanations fail, it's why they fail. They fail because they try to save an old picture of the universe by adding small patches. They assume the universe has always existed, always been full of stars, and always worked the same way. Distance and dust are attempts to keep that comforting idea alive. But nature doesn't cooperate. When every reasonable escape route fails, the honest thing to do is abandon the assumption. The dark sky isn't asking for clever excuses. It's pointing to a deeper truth. The universe hasn't had infinite time to reach equilibrium. It hasn't been glowing forever. It hasn't settled into a timeless, steady state. This second key point teaches a powerful lesson in scientific thinking. When simple explanations pile up and collapse one by one, it's usually because the question is challenging something fundamental. The failure of distance and dust tells us that darkness is not a local accident. It's not about where we are or what's in the way. It's built into the structure and history of the universe itself. And once you see that, you're forced to look for answers not in obstacles, but in origins. The moment you let go of the idea that the universe has existed forever, everything starts to make sense. The darkness of the sky stops being mysterious and starts behaving like a clue. The third key point is simple but profound. The universe has an age, and light has not had unlimited time to travel. The universe is about 13.8 billion years old. That number is not just trivia, it's a boundary. It tells us there is a maximum distance from which light could possibly have reached us. Light moves fast, but not infinitely fast. It travels at a fixed speed, and since time itself has a beginning, there are places whose light is still on its way, and places whose light will never reach us at all. When you look at a star 1,000 light years away, you're seeing it as it was 1,000 years ago. Push that farther, and you begin to see galaxies as they were millions or billions of years in the past. Keep going far enough, and you reach an era before stars existed at all, before galaxies formed, before there was anything capable of shining. Beyond that point, there is nothing to see, not because space is empty, but because the universe was too young to produce light. Darkness, in this sense, is not emptiness. It is unfinished time. This idea completely overturns the earlier assumption that every line of sight must end at a star. That would only be true if stars had existed forever. But they haven't. There is a cosmic horizon, a limit to what is visible, set by the age of the universe. Every dark patch of sky marks a direction, where light has simply not had enough time to arrive. This also explains why the universe doesn't glow uniformly even though it is filled with matter. The universe is still in the process of lighting itself up. Stars formed gradually, not all at once. Early on, the universe was hot and bright, but not in the way we imagine stars shining. Later, it cooled, clumped, and only then did the first stars ignite. Darkness is not a failure, it's a stage. What makes this especially striking is that we are not seeing the universe as it is. We are seeing a layered history. Near objects show the recent past. Farther objects reveal deeper time. And beyond a certain distance, time itself runs out. The blackness of the sky is literally the edge of what can be observed. So when you look up at the night sky, you are not staring into an endless abyss. You are looking at the boundary of time. You are seeing the universe's youth written in darkness. The sky is black because the universe has not existed long enough for every direction to be filled with starlight. This realization changes the tone of the question entirely. The dark sky is no longer a problem to be solved. It is evidence. Evidence that the universe had a beginning, that it evolved, and that we live at a moment where not all of its light has arrived. In that sense, the night sky is a clock. It tells you how old the universe is, not with numbers, but with silence. Even after you accept that the universe has an age, there is still one more piece of the puzzle that explains why the sky remains dark. The universe is not just sitting there calmly while light travels through it. Space itself is changing. It is expanding, and that expansion quietly robs light of its visibility. When light travels through expanding space, its wavelength stretches. This is not because the light is getting tired or running out of fuel, but because the space between the waves is being pulled apart. As the wavelength stretches, the light loses energy. What once may have been bright Visible light slowly slides into infrared, then into microwaves, and eventually into radio waves. To your eyes, that light might as well not exist. This means the universe can be full of light and still look dark. Imagine a glowing fire that slowly cools as it expands. The heat doesn't vanish, it just becomes less intense, less visible. The same thing is happening to the universe's light. It is being diluted by expansion. The energy is still there, but it's spread thin across an ever-growing volume of space. This effect becomes especially important when we think about the earliest light in the universe. Long before stars formed, the universe was hot and bright everywhere. But as the universe expanded, that light cooled. Today, it has been stretched so much that it exists almost entirely in the microwave part of the spectrum. We cannot see it with our eyes, but our instruments detect it as a faint, uniform glow coming from every direction. So in a very real sense, the sky is not black at all. It is glowing softly. We are just blind to that glow. This also explains why the sky does not slowly brighten over time as more starlight reaches us. Expansion keeps pushing much of that light out of the visible range. Even as new stars form and shine, their light is constantly being redshifted, stretched, and weakened as it travels through space. The universe never fills up with visible light the way an eternal, static universe would. What's beautiful about this idea is how gentle it is. There is no sudden cutoff, no dramatic wall of darkness. Instead, light fades away gradually, slipping out of view as the universe grows. Darkness is not the absence of activity. It is the result of motion on the largest possible scale. This final key point ties everything together. The sky is dark not because stars are rare, not because light is blocked, and not because the universe is empty. It is dark because the universe is dynamic. It expands. It changes. It stretches both space and the light moving through it. And that means every time you look up at the night sky, you are seeing expansion in action. You are seeing the universe doing what it does best, evolving. The blackness above you is not a void. It is a quiet record of a universe that refuses to stand still.